Using the law of sines, we need to show that in the triangle sine of b minus e over 2 equals to b minus e over a times cosine of a over 2. Okay, so we can either start from left hand side or from the right hand side, so that's totally up to you. But before that, before beginning, let's state the law of sines. Let us consider a triangle. We are going to consider an acute angled triangle. Now, we can also use an obtuse angled triangle or a right angled triangle. That's totally up to you. The law of sines is going to be equally true for all the three cases. So in this case, the acute angled triangle is represented by the vertices A, B, and C. Now, BC represents the side opposite to angle A. So we're going to represent it by the letter A in lowercase. Then the side AC, which is opposite to angle B, that will be represented by B in lowercase, and the other side AB will be represented by the letter C. Well, let's specify the law of sines. So the law of sines stated the ratio of side A to that of side of the angle opposite to it. So that's angle A. This will be equals to the ratio of side B to that of sine of the angle opposite to it. So that will be angle B. That will be equals to ratio of the side C to that of sine of the angle opposite to it, C. Now what we'll do here, if we suppose that these three ratios are equals to the constant lambda, then A can be represented as lambda times sine A. Then B will be represented as lambda times sine B. And C will be represented as lambda times sine C. So what we can do, if we replace B minus C over A on the right hand side with these values and do some algebraic manipulation, then we should get the expression on the left hand side. However, you can try it out. Whatever I will do here is I will go from the left hand side. So let's start with sine B minus C over 2. Now what we'll do here, so we have B minus C over 2. We have to make it in terms of sine B, sine E, sine C. To do that, all we have to do is multiply both numerator and the denominator with 2 times sine A over 2. So we have sine B minus C over 2. In the denominator, we have 2 times sine A over 2. The reason why we wrote in this particular fashion, because we are going to use the formula. So we know that the sum of the interior angles of a triangle, that's A plus B plus C, it sums up to pi radians. That means B plus C can be also expressed as pi minus A. Now if we divide both sides with 2, we have B plus C over 2, that's equals to pi over 2 minus A over 2. Now let's take the cosine of the angle on both sides. So if we have cosine of B plus C divided by 2, this will be equals to cosine of pi over 2 minus A over 2. Now what's the value of cosine of pi over 2 minus A over 2? That's simply sine A over 2. Because here we have an odd multiple of pi over 2, 1 times pi over 2, 1 being an odd number. The cosine must transform to sine and the new angle will be A over 2. Meaning cosine of B plus C over 2, so that's equivalent to sine A over 2. So we will consider only the numerator part and we will replace with the value cosine of B plus C over 2. So that means our new left hand side, so that becomes 2 times cosine of B plus C over 2 multiplied to sine B minus C over 2 whole divided by 2 times sine A over 2. Why did we go through all this trouble? Because now we can use the fact we know that whenever we have sine B minus sine C, so this is given by 2 times cosine of B plus C over 2 multiplied to sine B minus C over 2. So that means the numerator will now become sine B minus sine C divided by 2 times sine A over 2. Fine. Now, what we'll do? We have found out the value of sine B and sine C. We have already mentioned that sine B will be B over lambda and sine C will be C over lambda. So let's find it out. So we have B divided by lambda and C will be C over lambda divided by 2 times sine A over 2. Now let's do one thing. Let's multiply both numerator and the denominator with cosine A over 2. So we have B over lambda minus C over lambda whole divided by 2 times sine A over 2. But we will multiply cosine A over 2 to both the numerator as well as the denominator. In doing so, now we can use the fact that, okay, let's work with the numerator. We have 1 over lambda multiplied to b minus c times cosine of A over 2. Now, we can use the half angle formula here, which states that if we have sine theta, so that's equals to 2 times sine theta over 2 times cosine of theta over 2. So here theta is represented by angle A. We're going to get sine 2 times A over 2. So that means we have sine A in the denominator. We have 1 over lambda multiplied to b minus c times cosine of A over 2 whole divided by sine A. Now what is sine A? So we have defined that A is equals to lambda times sine A. So sine A will be A over lambda. So let's substitute it here. So we have 1 over lambda multiplied to b minus c times cosine of A over 2 whole divided by sine A. So that will become A over lambda. So we can factor out 1 over lambda from both the numerator and the denominator. And the final value is going to be b minus c divided by A times cosine of A over 2. And this is the expression on the right hand side, hence proof. Now, what we can do, if you start from the right hand side, all you can do is you start with b minus c over A times cosine of A over 2. So here, you can replace the value of b, c and a with their respective values, and you can, if you go in this path, so, and you are going to reach the left hand side. So this is the left hand side. So either way, it is going to give you the correct result.